During this project, we focus on the analysis, modeling, and construction of electrical circuits. Electrical circuits are fundamental to our society and all inventions within. Therefore, it's essential for an engineer to have deep understanding of the process and the operation of circuits, as they are the root of almost all modern inventions.
So the method that was applied was the mesh analysis, and it was found that the first mesh was of 0.95 million pairs. The current of the second mesh and the third mesh was of 0.34 million pairs. Then after that, it was applied the current between each resistance. So in case of the 18K was of 0.61 million pairs, so as the 6.8 kilo ohms was of 0.61 million pairs, and the 12K, 4.7K, and 27K kilo ohms was of 0.34 million pairs. And also the 51 kilo ohms was the only one who current was of 0 million pairs. So concluding that also the voltage would be of 0 volts in that resistance. So according to this, it was applied also the voltage, and it was said that V1 was equal to 10.9 volts, V2, which was of the 6.8 kilo ohms, was of 4.15 volts. The V3, which was of the 12 kilo ohms, was of 4.1 volts. The 4.7 kilo ohms was of 1.6 volts, and the voltage of the 27 kilo ohms was of 9.2 volts. And that was it.
Using the circuit diagram from Professor, we recreate the same layout in Tinkercad. We add the voltage source and all the resistors with their correct values. And to measure the voltage, we place one probe of the multimeter on one side of the resistor and the other probe on the other side. And we could see the voltage drop across each resistor. Then we duplicate this circuit of Tinkercad to measure current, but in this second version, we replace some wires with multimeters connect in series, and we switch them to the amperage mode and got the current values. And finally, with this simulation result, we can compare with our theoretical calculation and also with the measurements of the real circuit on the breadboard.
I will explain the implementation of the circuits on the protoboard and the process of measuring the voltage and currents in each electrical component. To begin, we assemble the circuit on the protoboard following the exact same connections in the theoretical analysis and the integral. We measure the match orientation of the power supply, the placement of the resistors, and the wiring to avoid short circuits or incorrect connections. Then we proceed with electrical measurements using the multimeter. We measure the voltage across each resistor by placing the probes directly on the terminals. Then to measure the current, we adjust the multimeter to the current mode and place it in series to each component to obtain the real current values. As expected, the real measurements show small variations compared to the theoretical and simulation variants. These differences come from normal factors such as resistor tolerance, internal resistance of the multimeter, and the small losses in the connections. Despite this, the results were consistent and confirmed that the circuit was assembled correctly.
In conclusion, with this work we were able to put our knowledge into practice by implementing theoretical methods such as the mesh method to determine current and voltage values in a circuit. We successfully modeled the circuit in Tinkercad to optimize time and materials when building the circuits on the breadboard.